And thank you, the other Eric, because what you've shown us is a pretty good way to save a few minutes of my presentation, which is a good thing, because I talked about a similar topic last week for 3 hours, and so the big challenge is to quench it somehow into 1 hour this morning. But 1 hour should be feasible, because it's basically two messages that I have. If my notebook wants to do it this way, okay. It's basically 2 messages that I have. One message is how can we succeed in doing design research in a well-founded, generic way that meets the expectations that the scientific community has to well-done research. That's one thing. And the other thing is to share my thoughts, our current thoughts, which are still thoughts and not really good, well-developed approaches, on how things might work different and might need to work different if we're talking about service systems that we design and not regular information systems. So, first, a few words on just positioning where I come from and what are the, let's call it, political considerations that made us think about certain things in a specific way. Then, as I said, what we believe is important to do design research in a competitive way. Competitive means competition for slots in A journals, where we have to compete with other disciplines and other approaches to research that have a different background, a different ideas on truth, different ideas on transparency, different ideas on many other things. And then I have an illustrative example, which is basically from civil engineering and not from information systems research, to, well, make it a little bit more interesting and probably focus a little more on that, what we can really transfer to many different fields, not only to information systems in design. And then I have 2 parts which discuss and reflect a little bit what's happening when we move from the regular design for deployment information systems design approach to what we feel is a more service-oriented, people-oriented, use-oriented design approach. All right, and backup will certainly not within my time frame. All right, political background. I'm from IS, so basically in everything we are talking about, there's always 3 main components. That's of course technology somehow, it's of course tasks, organization, processes, of course, and it's people. And that's probably the only thing that Eric, I liked your presentation very much, that probably could be a little bit more present and more prominent, because at the end, and that will be the final thoughts, we believe that the more we talk about services and service information, the more it will be necessary to really look more into how people behave, how people use things, and to design for use instead of for deployment. So, people, task, and technology, that's the background, and still there is a lot of discussion about whether there is a narrow understanding which requires all of these components to be physically present in the artifact, or a little bit more relaxed understanding where, for example, a suitable artifact could be to design a performance management artifact that does not necessarily include IT components, so software and hardware components. And that's basically the narrow or the low understanding is basically the big fights that we have from time to time with editors and track chairs. And that's basically, there's no real answer to it. Would be more appropriate or usable or useful. So it depends a little bit on kind of political understanding that you have of the field. Regardless of whether you have a narrow or wide understanding, what I see is that at the end we look at these IS artifacts, people task methodology, and how they are used in organizations. And of course there's theory building, there's a desire to understand what's happening, to explain what's happening, and to some extent to predict what might be happening. So that's where theory building takes place, that's where all the social science methodology comes in, that's what the mainstream is in some communities and in some countries, but not in all communities and not in all countries. And this builds up to a body of what you could call kernel theories that explain the phenomenon. And here we could stop if we were across the Atlantic, for example, because that's it in most places. Explain phenomena. Now, we're not across the Atlantic, but we are here in Europe, and so there are additional things coming into the field. For example, some way back from explaining to the phenomena, to innovating, moving ahead, doing something, solving problems. And there we have at least in our impression, we have two steps. And one is to construct generic solutions for generic problems. And another step to construct concrete solutions for concrete problems. Both are more the engineering sciences that come into the play here, and other social sciences. But these steps are different due to their different genericity. And there are different, as a consequence, approaches to do this. And there's a big discussion now, well, is only this here science and all the rest practice? Or are these two science and only the thing in the right lower corner practice? And again, that's a political question. Lies a narrow or wide understanding, and you could for weeks argue about what is your science definition and what is your consulting or practice definition. And of course I have an opinion on that, but of course other people have other opinions. And that's again the second part of the discussion that you usually have with editors or track chairs or whomever. So, how can we differentiate these three areas? I would say the important thing are two boundaries here. One boundary is the boundary between the objective truth and the objective usefulness. Do I just want to understand, or do I want to change something, solve a problem? That's an important one. And the other one is here the boundary between, do I look into something which is generic, or do I look into something which is specific and singular to some extent? So these boundaries are very interesting, and these boundaries we somehow have to take into consideration when talking about methodologies, about construction approaches, about the science of design. Because the science of design needs to be somewhere here. Here we have the science of explanation, here we have the science of design, and here we have the actual problem solving that's practiced. So, of course we need both. So that's one reason to travel across the Atlantic from time to time, because across the Atlantic people are building lots of theories that explain and predict important things. On this side of the Atlantic, lots of people create very useful generic solutions to solve problems, and at the end, the ecosystem of IS research needs both sides, and so it's a good idea to talk to each other and to see how these both partial communities can create synergies instead of fighting each other competing for scarce journal zones. Now, competitive means have a chance to publish an MISQ, for example. So, what needs design science research to be in order to have this chance? Well, the problem solving, we look at problem solving, it should be relevant, important problems. So we should be able to prove that the design problem we're looking at is relevant and important, and I think most of us will have no big problem in proving that. The means is the artifact, and Eric already said a little bit on what the diversity of artifacts is. There are a lot of artifact types available for us. They all are at the end technological rules, which does not necessarily mean it's information technology, it's a piece of software, it's a piece of hardware. No, it's a technological rule in the sense of technique, the Greek word technique, which is basically a means for something. Something that you do to achieve something. So a means and relationship. So that's what's coming out of design research. And genericity. And that will be the main question, the first main question I will be addressing. How do we succeed in guaranteeing a certain amount of genericity of our artifacts that helps us to be competitive? Then of course we have to prove that these things are innovative, they go beyond the state of the art. We have to specify our requirements, we have to systematically see what's around there in literature as well as in practice. So that's the proof of innovation. Then it's a groundedness. So we should also look at all the other guys' work that explain things and predict things, because that's basically the explanatory theory that should be the foundation for the design theories. So they explain the phenomenon, and if we want to create a means for using something, of course we need these explanations, we need to translate these explanations into design theories and apply design theories. So it's important to use that. And as all the big references say, there should be a search process, there should be iterations somehow visible or documented, and of course we need to evaluate utility. It should do better than what was around before. So basically that's my criteria system when I have to review a submission or to make an editorial decision. Now, what kinds of artifacts? I think that I can be very fast here. Eric already explains a few of these artifact types. They fit quite nicely in what Schmielewitz said. It's the hierarchy of concepts in social sciences, the basis terminology, and then we're talking about cause-effect relations on that basis. And on that basis, we can talk about means-end relations, which he calls technology. So that's very close to the technological rule from Van Aken's seminal work. And based on technology, we probably could talk about normative statements. We usually don't dare to, because it's very thin ice we're walking on. And at the end, it's actual soil choices, it's the instantiations that we at least need to prove the utility of what we're doing. And that fits quite nicely to all the things we are talking about. Eric had some of them in his presentation, and it fits also to the seminal works that we had in design research, for example, March and Smith, that were already mentioned, that see these four artifact types. And as you see here, if you match the March and Smith taxonomy to the Schmielewitz taxonomy, there are two fields of discussion. One is what's about theory. Are theories part of design research, and which role they play? We should also have a theory, of course, if we call ourselves scientists. That's discussion number one. Discussion number two, should we talk about normative statements in design research? And that's still an ongoing discussion at the respective conferences.